Okay, good day. This is Honors Algebra 2. I am Mr. McCulley, and this is the video lecture presentation for 8.1, Simplifying Rational Expressions. Let's get right to it. Please keep in mind that I am making available to you guys the Zoom meetings at 11 a.m. Check the stream for the daily invitation. Please make sure that you're keeping up on all the practice work. I'm trying to keep it short and keep them small. But if you get yourself behind, you're going to have some problems. Today we're going to be talking about simplifying rational expressions, and we're going to also be simplifying some complex fractions. And so what I thought I would do is do a simple review of what it means to simplify a fraction, and then we will apply that to something that's a little bit more challenging. So when you are asked to simplify this fraction 15 over 20, what you are actually doing is you are actually factoring both of these. So 15 factors into 3 times 5, and 20 factors into 4 times 5. Now, anytime you have something over itself, a over a is always equal to 1, provided that a is not equal to 0. And that's the case. And so what we're actually doing is we're looking for a common factor in the numerator and a common factor in the denominator so that we can cancel those out and say that the final reduced fraction is 3 over 4. Now, when we have rational expressions, we are essentially going to do the same thing. So, simplifying fractions, elementary rational expressions. For what values of x okay, so this is me asking a question, I apologize. For what values of x is this rational expression undefined? And then they're going to ask us to simplify it. So if I'm going to answer part A, what values of x is this rational expression undefined? Well, it is undefined whenever you have a division by 0. All right. And so what we're going to do is we are going to factor all right, so we know that the denominator here is a difference of squares. And so since it's x squared or a squared minus b squared, we can factor that into a minus b times a plus b. And so it's going to end up factoring x minus 3 and x plus 3. And then this is not a difference of squares, but it is something that we can factor. There are two factors of -6 that add up to -1, and they are x minus 3 and x plus 2. And so to answer this first question, what values of x is the rational expression undefined? It is undefined for values of x that are equal to, well, 3 makes this factor 0, so 3 is our first one. And -3 makes that factor 0, so -3. So for x equaling to plus or minus 3, we have an undefined. And then for b, if we want to simplify the expression, I see that I can cancel out an x minus 3 in the top and an x3 in the bottom. And so my final answer for this one is going to be x plus 2 over x plus 3. Put a box around that, and we are done. All right, next one. Canceling across excuse me. Canceling across multiplication, we can simplify this product of fractions by canceling before we actually do the multiplication. And so I notice that along this diagonal right here, from the upper left to the bottom right, that I have a factor of x in both terms. So I can cancel out that x in both of those terms. I also notice that I can I can cancel out a factor of 3 in those two values. And so 3 divided by 3 is 1, and 9 divided by 3 is 3. And now by canceling at the beginning, I'll make this multiplication a lot easier. 5 times 3 is 15. 1 times 4 is 4. And even though this is an improper fraction, we will not have to do anything with it because it is reduced. 4 does not share any common factors of 15, so 15 over 4 is our final answer for that one. Next, we start getting into things that are a little bit more challenging. This is an example from the book. And so again, I would suggest you make sure that you factor each of these as best you can. So I'm going to rewrite this thing, and I notice right off the top there's nothing I can do with this 3y, so I'm going to leave that there. There's nothing I can do with this y minus 8, so I'm going to leave that there. But let's see, are there two factors of negative 24 that add up to positive 2? The answer to that is yes. I can go y minus 6, and I can go, actually, let's go y plus 6, and then y minus 4, and y times y gives me the y squared. Y times negative 4 is negative 4y. 6 times y is positive 6y. With a negative 4y gives me 2, and then positive 6 times negative 4 is negative 24. So I have that factorization. I can't do a whole lot with this 15y squared, so I leave that 15y squared right there. Two factors of 32 that add up to negative 12. Let's see here. How about negative 8 and negative 4? Yeah, that'll work. So y minus 8 and y minus 4. And so now I look at this thing over here, now that I have it completely factored. I see that I can factor out a 3 from both of those values and make it a 1 and a 5. I can cancel out one y up top, and I'll cancel out that y there on the bottom. I can cancel out a y minus 8. I can cancel out a y minus 4. And that will leave me, it looks like I've canceled out everything except for y plus 6 on the top. And on the bottom, it looks like I've canceled out everything but 5y. So we're going to go with that as our answer there. Moving on. Here is a division. So this one is not just a simplification. We are actually asked to divide here. So remember, so when we divide fractions, we are going to flip the second fraction and multiply. So I'm going to rewrite this first one as 14c squared f to the fifth over 9a squared. And then I am going to multiply by 18ab to the third over 35cf to the fourth. Okay, so when I look at this now, canceling across the diagonal, I can cancel out a c from the numerator and the denominator. I can cancel out 4 f's in the numerator and the denominator. I can cancel out an a in the numerator and the denominator. Can't do anything with that b, but I see that I can factor out a 9. And when I factor out a 9 from the 18, I'll have a 2, and I'll have just a 1 there. And then there is a common factor between 14 and 5. I can factor out a 7, which will leave me a 2 there, and a 7 on the bottom. And when I look at what's left in the numerator, I have a 2 and a 2, so 2 times 2 is 4. I have a c and a b to the third, so c, b to the third. And then 1 times 7 is just 7. and I'm left with an a to the first in the bottom. And so that is my final answer for that one. All right, this last one, again, simplify. And from the last one, we're dividing a fraction by a fraction. So again, in this first one, we are going to flip the denominator and multiply. So I'm going to make this x minus y over a plus b times a squared minus b squared over x squared minus y squared. And here I'm going to factor because I see that a squared minus b squared and x squared minus y squared are difference of squares. Okay, two f's. All right, and so I'll have x minus y on the top, a plus b on the bottom. Those things don't factor, but I can factor this thing to a minus b times a plus b. And in the bottom, I can factor that one to x minus y times x plus y. Put some equals there. And then we're going to cancel. And so I see that an x plus y and an x plus y cancels. Or excuse me, an x minus y and an x minus y. An a plus b and an a plus b cancel, leaving me only with a minus b over x plus y. And that is our reduced form. Well, that's all I have for today, folks. So we're going to have Mr. McCulley's fun fact of the day, and Mr. McCulley's fun fact of the day are going to be just some random facts about stuff in general. Today's McCulley fun fact is actually about me, myself. The fun fact of the day, these are our home cats. I didn't name either of them. They are my wife's cats. We have Bruce, who is a tuxedo cat who has face markings very much like the Batman, so my wife named him Bruce. And then we have Archie, who was part of a litter, of Reggie, Betty, Archie, Veronica. I don't know if there was a Jughead, but there might have been. And that's how we got the names of our cats. Well, that's all I got. Have a good day. Bye.